Solving simultaneous equations, algebraic methods, starting with substitution. A point that I didn't mention before, by the way, which I want to mention, parallel lines, you can tell this easily when you're graphing, parallel lines have no intersection. There will be no solution to a pair of simultaneous equations if the two lines are parallel. I should have mentioned that. You can check by looking at the gradient. If the gradient is the same, they're parallel, there won't be a solution, don't bother trying. So it's always a good idea to have a quick look. Gradients are different, there will be a solution, we'll try to solve it. So, when you are solving a set of simultaneous equations algebraically, you start by writing down the two equations, one over the other, and labeling them, equation 1 and equation 2, and put that in brackets or in a circle. So equation 1, equation 2. So let's do the steps in a different colour. This is part of your working here in my lovely green pen. Over here in pink is my instructions. You must do this. You must not get lazy. Now, as I said in the previous video, algebraically, what we are aiming to do is to get rid of one of the unknowns. This is a nice example for how, because y equals negative 3x plus 2, but y also equals 7x minus 8, which says that this equates to this. There's no need for the y's at all. Effectively, we are taking this value of y, 7x minus 8, and substituting it in for this y here. And we say, I am going to substitute equation 1 into, so I'm putting equation 1 into equation 2. And so you are very definitely and clearly stating that you are substituting. At every step of solving simultaneous equations, you tell me what you're doing. So we take equation 2, y equals 7x minus 8, and where the y is, we put this value of y instead. And now I've got an equation where there's only one pronumeral, and I know how to solve that. So here I'm going to solve it for the pronumeral that's left, which is x. If it was y left, I would be solving for y. Remember, we're not writing this down as part of our solution. This is my instructions to you. So we gather these to the same side. Let's get rid of this negative. Add 3x to both sides, and add 8 to both sides, so 10 equals 10x. Well, that's nice and easy. Keep solving. X equals 1. You're not done. You've got your solution for x. You need to substitute that back into one of these to get the value of y. It doesn't matter which, just choose the one that's going to be easier. Either one really. Sometimes it's very obvious. When we've got one in terms of y and one isn't in terms of y, choose the one that's in terms of y usually. So you substitute the known value and you say that you're doing that. Substitute x equals 1 into which equation? Let's use equation 1. Write equation 1. Substitute that value of x. Negative 3 times 1 is negative 3, plus 2 is negative 1. Now you've got your x value and your y value. You state your solution. Therefore, x equals 1, y equals negative 1. But you also have to check somewhere separately to your solution, write a little check. Now you know this works for your first equation because you just did it, but double check that you're okay for your second equation. This isn't a part of your formal solution, but I want to see this check. You might as well not get it wrong. Y equals 7x minus 8. Negative 1 equals 7 times 1 minus 8. And as long as you get to there where it's nice and obvious that that's correct, make sure that it works, your solution works for both equations, otherwise you might get it wrong. So that's one example of substitution. We'll just do a second example. Here you can see both of our equations are not in terms of y. One is, one isn't. There's another method we could use called elimination, but we won't. We can use elimination or substitution, and we're learning substitution. So you write and label your equations. Now if one is in terms of y, chances are we're going to substitute this value for y into where that y is. So we're substituting 2 into 1. Yes, you could rearrange this so you had a value for x. Let's not go there, that would be silly. We've got a value for y, we're going to use it here. Say that we're doing that. Substitute equation 2 into equation 1, because this is going into equation 1. That will be 2x minus 3, and instead of the y, I want the full value of y as stated here, x plus 3 equals negative 8. Solving this for x. Now I've got brackets here, and remember that negative goes with the minus 3 there, so this will be expanding. I'll have 2x, negative 3 times x is negative 3x, negative 3 times 3, so minus 9 equals negative 8. Gather your like terms before we do anything rearrangey. That's negative 1x. I know we don't need the 1, I like to keep it in there just because it's clear. Gathering those, and we can probably deal with this 9 at the same time. Minus 9, so add 9 to both sides, equals 1. Divide by negative 1 on both sides, x equals negative 1. So you've solved for x. Then here you see what I was talking about before, where one equation is much easier than the other. Don't substitute into equation 1. You want to find y. Equation 2 is already in terms of y. So we're going to substitute x equals negative 1 into equation 2. Negative 1 plus 3 is 2. State your solution. Therefore, x equals negative 1, y equals 2. And over here somewhere else you do your check. You did your check for equation 2. You must check equation 1. Substitute in your values. Two times negative 1, negative 2, minus 6 equals negative 8. Yes, you're correct. You have checked your answers. So make sure, please, that you follow the required steps. I must see perfect working. You set it out down the page like this. You write your equations one under the other. You label them 1 and 2. You state what you are doing. You solve for one pronumeral. You say that you're substituting that solution into one of the equations to get your other pronumeral. You state your solution clearly, therefore x equals 1, y equals negative 1, and you do your check. This is not a time to be lazy. You need very meticulous, accurate working, please.